This chapter 8 is about measuring. In social science, we have to measure variables in individuals. And this can get tricky. As you will see in this chapter, there's a lot of room for error. And when you know that, you're better equipped to avoid making these errors. So we do have to measure variables in subjects if we want to study them, correlate them, describe them. Some variables are very easy to measure, especially in science or daily life. You can measure easily weight, length, volume with a measuring tape, a scale, or a measuring cup. But in social science, sometimes it gets very tricky. For example, how would you measure the stress level of a person or the happiness of a person or a nation? That's tricky. There's no exact safe tool for that. So we have to invent and to develop some instruments in social science to measure things that are not easily measured. Usually, to measure a property of a subject or a variable, we do assign a number. We can assign other things than number, like low, medium, high, but let's work for now with numbers. In some cases, as I said, it's much easier. If you want to measure the height of your bike frame, it's 21 inches, you take a measuring tape. If you want to measure your own weight, you will use a scale. So in some cases, it's very easy. You have two important terms here to remember: instruments and units. So instruments is what we use to make the measurements, and units are how we express the measurement. So in the case of your bike frame, your instrument will be a measuring tape, and your unit, still today we use inches for that. If you want to measure the weight of a potato bag, you will use a scale as an instrument and pounds or kilograms as unit. But what about your stress level? What would be the instrument? What would be the unit? You could, for example, develop a questionnaire as an instrument, asking people, do they sleep well? How many hours every night? How many minutes in average they take to get the sleep? Do they have skin problems, or are they happy? Are they fighting with people? This is all things that could be asked subjects to measure their level of stress. And how do you use units for that? Do you give points? Your questionnaire can have 25 questions, 4 points for each question. So if I score 76 on 20, I'm pretty much stressed out. So these are all things we have to think about. And when you read results of social science on things like happiness or stress or attention span, or levels of aggressivity, you all have to think about it. How did they measure these variables? Can we trust their measurements? So choosing the right instruments and units can be pretty tricky. Example, if you want to measure the attention span of young boys in school with ADHD, you want to study the impact of medication, maybe. How do you do that? Do you get the help of the teacher in rating how well they are paying attention on a scale of 1 to 10, depending on their general behaviors? Do you sit there and observe the boys in school, in the classroom, and count how many minutes or maybe seconds they can stay quiet? Do you rate them yourself? You have to think about these things. Really, the first step in making good measurements in social science is to clearly define the variable you want to measure. We call it giving an operational definition of the variable. So how do we define attention span? Is it the number of seconds or minutes the boy is keeping quiet with eyes directed to the teacher, or is it the general behavior? Is it how many seconds or minutes they are able not to move or not to speak? So once a variable is clearly defined, now it becomes easier to develop an instrument with the right units. And what we want in social science, as in science, is to have accurate measurements. Some of them are easier to be accurate. For example, if I count minutes or seconds and now I use a watch, that's easier to be accurate. And if I use points or if I use categories, then it's maybe less easy to be accurate. A very important concept when we measure variables is the validity of a measurement. Remember that concept. Validity. When a measurement is valid, it means it measures really what it should measure. Example, if I want to measure the velocity of cars, how fast they go, then I will use a radar speed gun. So this is the right instrument. It really measures the speed, so it is a valid instrument. If I want to measure the blood content, the alcohol content in your blood, well, if I'm a police officer, I do have the right instrument. It's called the blood alcohol calculator, what you blow in when you pulled off by the police. So this is an instrument that is valid in this case, and valid doesn't mean it's accurate. It means it really measures what it has to measure. It really measures blood alcohol content. If I ask someone to touch his nose while closing his eyes to measure the blood alcohol content, maybe it's not so valid. Maybe you're totally drunk and you're totally able to touch your nose and close your eyes. So it might be a better way to measure your space coordination, but not your blood alcohol content. So asking you to touch your nose is not a valid way to measure your blood, your alcohol content in your blood. There's more valid ways. For example, a blood alcohol calculator. I might have a very valid way to measure something. For example, my blood alcohol calculator to measure the alcohol content in blood, but still make mistakes because sometimes there are errors in measurement, even if it is the right instrument, even if the measurement is valid. A measurement can be biased. This happens when my instrument systematically overestimates or underestimates the true value of what it measures. For example, if my blood alcohol calculator systematically says someone's drunk, someone has too much alcohol in blood, well, this is bias. This is an error in measurement that is always done on the same side. Another example, I have a thermometer in my car that says the temperature outside, and my thermometer is very optimistic. It always gives 2 degrees higher than what it really is. So this is a bias. It is a systematic error, always 2 degrees above the real measurement. So this is what we call a bias, always an error that is always made in the same direction. Bias is not the only kind of error in measurement. A measurement can also have random error. And this is if you measure many times the same thing, you never get the same measurement. And the error is made on both sides. Sometimes it is higher than it's supposed to be. Sometimes it is lower than it's supposed to be. Suppose that my blood alcohol calculator sometimes gives me a number that is too high, but sometimes gives me an error that is too low. And it's never the same error. So this we call it a random error. It is done on both sides. It is not biased. It is random here. So if the random error is big, my instrument, my measurement is not reliable. So reliability is another good quality of a measurement. Reliability means the accuracy of a measurement. So we have learned here two good qualities of a measurement. It has to be valid. It really has to measure what it's supposed to measure. And it has to be reliable. It has to be accurate. We also have learned two kinds of errors in measurement. There's bias, when the error is always made on the same side, and there is random error, when the error is made on many sides, depending on when I measure. When we measure in social science, as in science, it is always better to present rates than counts, because rates present more accurate views of things. Example, these are true numbers here. There were 132 murders in London, England, in 2018. And at the same time, there were only 16 murders in the city of Ottawa during the same year. So if you read only the counts here, oh my goodness, 16 murders in Ottawa and 132 in London. London is a very dangerous city, but maybe not, because you have to take into account the population of each city. Ottawa has around 1 million of population, and London has 9 million. So London is a much more populated city. So if we use rates in Ottawa, it is 16 citizens per million being murdered. And in London, it's 14 per million. So the rate is higher in Ottawa, even if numbers are lower.